Welcome Year 9 students. Today we're starting a new chapter. We're looking at probability. We've talked a little bit about this in class. So let's carry on. I've got some questions here. I'm going to go through the ones that I've set you to do. We've got two tetrahedral dice. They are four-sided dice. So they're numbered 1 to 4. And we've got to copy and complete this two-way table. So imagine dice 1 got a 1. And you can see here that dice 2 is also getting a 1 at that point. So we can get a 1 and a 1. We can get a 2 and a 1. That's when we've got a 2 here and a 1 there, right? And the next one is going to be a 3 and a 1. Okay, next line. We're going to have 1 and a 2. 2 and a 2. 3 and a 2. And then this one's 4 and a 2. So we're just looking and finding all of the different combinations that we can make. And then we've got 3, 3, and then we've got 4, 3. Just try and keep it consistent. And then this last one, 1, 4, 2, 4, 3, 4, and 4, 4. So that's how we'd fill that table in. And part B, we have to find the probability of the score on the two dice not being the same. Well, if you look at it, you can see same here, same here, same here, same here. And if you look at the array that we've got 4 down and we've got 4 across. So there is a total of 16 possibilities, and the ones that are not going to be the same is 12, because 4 are the same and there's 16 possible ones. So if we go 16 take away 4, we get 12 16th, and we can simplify that down because 4 goes into both of those, and we should see that that's 3/4. In part C, what is the probability of the score on the dice being the same? Well, obviously that's those 4 out of 16, and we can say that that is equal to 1/4. So that's nice and easy. Let's move on to number 2. Okay, now 2 coins with heads, H, and tails are tossed, and we've got to complete the diagram. Okay, so this is a tree diagram. So first of all, you've got your first toss. This is coin 1. And you can either get a heads or a tails. And then you're going to toss the second coin, coin 2, and you can get heads or tails. But remember, there's different options, because you might have got a tails with the first coin, and which means you could get a heads and a tails with the second coin as well. So altogether, you can see that there are 4 options. You could get a heads and a heads, or you could get a heads with the first coin and a tails with the second coin, or you could get a tails with the first coin and a heads with the second coin, or you could get a tails with the first coin and also a tails with the second coin. So those are your different options. Now B, what's the probability of getting tails on both coins? Well, assuming that these are all 50% chances, you know, this is a half chance here, this is a half chance here, half chance, etc. You can see that each of these is a 1/4 chance. There's 4 options and they're all equally probable. And you can see that the chance of getting tails on both coins is this one here. So we can say it's 1/4. What's the probability of not getting tails on either coin? Obviously, if you're not getting tails on any coin, that's this one here, heads, heads, which is also 1/4. Okay, now we're moving on to question 3. So for question 3, we have 4 different colours of pen in the tin. Just 4 colours, red, green, blue, and black. And we need to find out the probability of black. Now the key thing here is to remember that these are the only 4 options, and all options must add up to a probability of 1. 1 is certainty. So all we need to do is find out what the red, the green, and the blue add up to, and then we subtract it from 1. Okay, so what could we go into here? Let's go into 20ths. So we get 6 20ths plus 4 20ths plus 5 20ths. And this gives us 15 20ths, which means that the black should be 5 20ths or 1/4. And if we just do a quick check on that on our calculators, we can go add them all up and make sure that that adds up to 1. And it does. So that's fine. We're right. Moving on to number 6. Mr. Wood and Mrs. Boyd teach the same year. The school photograph, they don't want to wear the same colour clothes. I don't know why. And Mrs. Boyd has blue, white, and red blouses, and Mr. Wood has blue, purple, blah blah blah. And we've got to copy and complete this diagram. So, well, I'm going to try and complete on the diagram. Hopefully you can see it clearly. So we're going to go blue here, so BB, and then we're going to go blue W here, and then we're going to go blue red here. Then we're going to go purple blue, purple W, purple red, and then going to go white blue, white red, and then we're going to go green blue, green white, and green red. Okay, so those are all of the different possibilities. Now that we've done that, assuming the teachers do not plan what they are wearing together, what is the probability that Mrs. Boyd wears red and Mr. Wood wears white? So we just got to look at, okay, where does she wear red and where does he wear white? So you go, are there any options of that? Red for Mrs. Boyd, red, and white. I think that's here. This is this one here. And you can see that there are a total of 12 options, right? We've got an array that's 4 by 3, which is 12, so it's out of 12. And there's only, it seems to me, one option where they're wearing those particular colours. Now let's look at part 2. What's the chance that they both wear blue? They both wear blue is going to be 1/12 again. If you look at the diagram, there's only one place where that's true. Now, the last part of this is we've got to find out the probability they do not wear the same colour. So what we're going to do for this is we're going to find out all the times where they do wear the same colour. So we've got a white, we've got a blue. We're going to ignore those. Do we have a red? No, we don't have a red. So there's, out of the 12 options, there's 2 where they do wear the same colour, which means there are 10 where they don't wear the same colour, and we can simplify that down to 5/6. Okay, let's move on. A couple more questions here. Number 8, we are drawing a, what are we trying to do here? Picking a word, a letter at random. Okay, now I'm going to be naughty and I'm not going to draw a tree diagram because I think it would be much wiser for us to draw a sample space diagram. Okay, I think that would be easier. There we go. So we can have CH, we can have CA, we can have CT, we can have AH, we can have AA, we can have AT, we can have PH, we can have PA, we can have PT. So here's my sample space diagram. Now, we're going to do part B. What's the probability of both letters being A? So that's this one here. So that's 1 out of, and you can see this is a 3 by 3, so that's 1 out of 9. That's part 1. Let's do part 2. The probability of only one letter being A. Okay, so for this, all the ones where we've got one letter being A, here, 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 here. So that's 4/9, as you can see. And part 3, at least one letter picked being H or P. H or P, so I'm going to circle with green. That's an H, that's an H, and it says at least H, so you can include when you've got both an H and a P. Here's another P. Do we have a P here? No. Do we have a P here? Yes. Okay, I think just quickly that is going to be 5/9. So I'm going to write 5/9 down here. 5/9. Okay, now if you were drawing a tree diagram, I'll just quickly show you. It's going to look like this. Right, so you're going to have 3, so make H, A, T, and then from there you're going to have 3 options coming off each branch, and those 3 options are going to be C, A, P, right? Okay, and you can see why I chose not to do that, because it's not a cool way of doing it. Okay, number 10. Okay, a blue and red card are chosen at random from the set of cards. What's the probability that at least one of those cards is even? So we're choosing one blue and one red. So what I'm going to do is I'm going to set up a sample space diagram. Here's my blues. 1, 2, what have I got next? 3, 4, and 5. Okay, 3, 4, and 5. That's my blue. And then I've got my reds here. So I've got 3, whoops, let's go in order. 1, 2, 3. Okay, so I've got, and I'll just do these middle ones with the same color. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. Now, we can answer, what's the probability that at least one of the cards is even? Okay, so we're looking for all the ones with at least one even. One even, all of these ones, right, because they've got 2s. We can have 2 evens, right? We can include this one because it says at least one. Not even, even, not even, even. Okay, and now we count them up. So it looks to me like we've got 5, 9. I think we've got 9, and if you count our array, it's 3 by 5, so it's 15 total, and 9 of them give us what we're looking for there. Okay guys, well I hope that gives you a good introduction to the probability chapter. Let me know if you have any questions, and take care.